In this video, we'll talk about how to find the magnitude and direction of a vector. So if we have some vector with a horizontal component of A and a vertical component of B, then we say the magnitude of that vector is calculated as the square root of A squared plus B squared. We can then find the direction of that vector by knowing that the tangent of theta, or tangent of the direction, is equal to B over A. So then from that, we know that the direction, or the theta, is equal to the inverse tangent of B over A. So let's work through a few examples. Let's say we're told some vector has a horizontal component of 3 and a vertical component of 4. How can we find the magnitude and direction of this vector? Well, the magnitude, we said, is equal to A squared plus B squared. So in this case, A squared, A is 3, so we have 3 squared, and B is 4, so we have 4 squared. So we get the square root of 3 squared is 9, plus 4 squared is 16. So that's 9 plus 16 is 25. So the square root of 25, that's 5. So the magnitude of this vector is 5. Now let's see if we can find the angle. So we said that the angle, or the direction of this vector, is the inverse tangent of B over A. So that would be the inverse tangent of B is 4, and A is 3. So if you punch that into a calculator, the inverse tangent of 4 over 3 is about 53.13 degrees. So those are our answers. The magnitude of this vector is 5, and the direction is 53.13 degrees. All right, let's try another example. Let's say we have a vector with a horizontal component of -12 and a vertical component of 5. How can we find the magnitude and direction of this vector? So the magnitude is equal to A squared plus B squared. So A is -12 plus B squared. B is 5, so we have 5 squared. So we get -12 squared, or -12 times -12, that's 144, plus 5 squared, that's 25. So 144 plus 25, that's 169. And the square root of 169 turns out to be 13. So 13 is the magnitude of this vector. Now let's see if we can find the direction. So we'll say theta is equal to the inverse tangent of B over A. So B is 5 and A is -12. But when working with inverse tangent, we'll always use positive numbers. So what we're going to punch into our calculator is the inverse tangent of 5/12. And we'll find that that's about 22.62 degrees. But here's the catch on this one. If we imagine this vector, so if we draw it, we said the horizontal component is -12. So in the x direction, we're going -12. And the vertical component is 5. So if we're out here, 12, and we're going up 5, then our vector lands somewhere out here. This isn't drawn to scale, but just to give us an idea, -12, 5. Now, when we found the tangent of the inverse tangent of 5/12, we found that that angle is 22.62 degrees. But our vector lands over here in quadrant 2. So really we're trying to find this angle. If we imagine our unit circle starting from 0, we're trying to find this angle that ranges from 0 all the way to here. Well, we know that if we did a half revolution around the circle, we'd be at 180 degrees. And we found that this angle right here is 22.62. So this angle right here is also 22.62 degrees. So to find this angle starting from 0, we just need to do 180 minus 22.62. So if we do that, 22.62, we get 157.38 degrees. So that is what this angle is, starting from 0 all the way out here to -12.5. This is 157 0.38 degrees. So we found the magnitude to be 13, and we found the direction or the angle to be 157.38 degrees. All right, let's try one more example. Let's say we're told that a vector has the following horizontal and component form: I plus the square root of 3 times j. Now sometimes a vector will be written like this in component form, where the first chunk is the horizontal component and the second chunk is the vertical component. So if we want to find the magnitude and direction of this vector, we can say the magnitude is equal to a squared plus b squared. So a, in this case, is just 1. It's the coefficient in front of the I. So we'll say 1 squared. And b is the coefficient in front of the j. So the square root of 3 squared. So we get 1 squared is 1, plus the square root of 3 squared is just 3. So 1 plus 3, that's 4. So the square root of 4, that's just 2. So the magnitude is 2. And now to find the direction, remember we say the direction, or theta, is the inverse tangent of b over a. So in this case, b is the square root of 3, and a is 1. So that simplifies to the inverse tangent of the square root of 3. And if you punch that into a calculator, you'll find that that is exactly equal to 60 degrees. So the magnitude of this vector is 2, and the direction is 60 degrees.